Alright, this is my combined spectrum analyzer, function generator, and oscilloscope for Engineer 267, summer 2015. Alright, I'll go ahead and give this a run. So we're starting off with a 50.2 hertz sine wave. See on the spectrum analyzer that we have frequency content at 50 hertz as expected. Alright, so we add a DC offset to that signal. Okay, we change the amplitude of that signal. We have a different volts per division scale over here, so we can zoom out if we want to. You'll see a cursor screen that's brought up there, and a milliseconds per division. Here's that cursor. Notice that I can just set it right here and see the X and Y intercept about 0.96 volts at 0.022 seconds. It's kind of a neat thing to add on here. Alright. Frequency we can take all the way up to 20,000 hertz, and at that rate it is well, it's always sampling at 45,000 samples per second, so it's above the minimum required here. Alright, so this is for a sinusoid. How about we do some different signals here? Got square waves, and triangle wave, and sawtooth, and DC. And then we also have the ability to add various types of noise to the signal. So here's sinusoid with uniform white noise, and Gaussian white noise, and various other types of noise like Bernoulli. Over here we have the minimum voltage, maximum voltage, peak-to-peak voltage. The mean voltage of a sinusoid is of course 0. I have a table here to collect data from for a certain period of time, so I'll go ahead and reset it. And as I do this, I've noticed that it tends to speed up the signal quite a bit, and then I turn it off. So it's not particularly stable, but see it stores the values of the mean and min. I'm having difficulties with the maximum right now, but this is so far working. And then the ability to save the file, as you'll see here. I can go ahead and do that, and that'll save that data table there. Other than that, you'll have the elapsed time of this recording. So there you have it. This is my project. Thank you.